Alright, so this video we're going to look at basic identities, basic trig identities. This is the first video. There's going to be 5 more after this one. You can see them in the playlist. They're right up underneath this video in the playlist. There's going to be about 5 more videos on trig identities. So I would encourage you to watch all of those, and hopefully after that you'll be pretty good with trig identities. So let's go ahead and get started on this one. So we've got the reciprocal identities. You've seen this in an earlier video if you've been watching them. You've got sine is 1 over cosecant, cosine is 1 over secant, and tangent is 1 over cotangent. And then the same thing with cosecant, secant, and cotangent. It's just these identities, it's just saying that sine and cosecant are reciprocals of each other, cosine and secant are reciprocals, and tangent and cotangent are reciprocals of each other. All right. Like I said, these were in earlier videos. And then we've got tangent and cotangent in terms of sine and cosine. Writing them as a quotient. So tangent is sine over cosine, cotangent is cosine over sine. Now, as far as these identities go here, these two, you don't really need to memorize cotangent, because it just memorized tangent, and you know that tangent and cotangent are reciprocals from up here on the reciprocal identities. So tangent and cotangent are reciprocals. So if tangent is sine over cosine, then you know cotangent is just the reciprocal. So that would just be cosine over sine, which we get over here. All right. And then we have the Pythagorean identities. Sine squared plus cosine squared is 1. I think for the most part, trig students, they memorize that one. That one everybody knows. But the next two, cotangent squared plus 1 is cosecant squared, tangent squared plus 1 is secant squared. Now, these are the two that students tend to forget. But look, let me show you this real quick. If you memorize this one, sine squared plus cosine squared equals 1. So we've got sine squared plus cosine squared equals 1. So if you memorize this one, you can get the other two. So if I come through here and divide everything by cosine squared like this, then sine squared over cosine squared, well, we know sine over cosine's tangent, so that would be tangent squared x plus, and then cosine squared over cosine squared is just 1, and then 1 over cosine squared, well, we know 1 over cosine is secant, so this would be secant squared. And see, that gives you this identity. And then the same thing, and I'm not going to do it, but if you come here and you divide this through by sine squared, you'll get the other one. Okay? So, you know, try to memorize them, but if you can't memorize all of them, at least memorize this first one right here, and then you can get the other two from that. All right, so this one, this right here is just, it's really nothing new. I mean, you should know how to do the full method. You just probably haven't done it with trig functions yet. So let's multiply these out. So we've got sine times sine. That is going to give us sine squared. So all we're doing is fulling it. So sine times 3 is 3 sine. And then 2 times sine is 2 sine, and then 2 times 3 is 6, and then we combine like terms. 3 sine x plus 2 sine x is 5 sine x plus 6, and there's your answer. Now, as far as the way I worked it, I mean, I wrote everything out and then combined the like terms here. I mean, I understand you're probably at the point where you can probably go from this step to this step, and that's fine. I mean, there's really no need to show this step unless you just need to. Okay, and if you do show this step, that's fine. All right, let's look at this one. we got 1 plus tangent times 1 minus tangent. So remember, this one looks like what? This right here is a plus b times a minus b, which is a squared minus b squared, right? So, well, in this problem, what's a? Well, a is 1, b is tangent. So that's going to be 1 squared, which is what? 1, minus, and then b squared, which is tangent squared. And there's your answer. All right. Now, this one, now remember, on this one, we got 2 sine alpha plus 1. So remember to square that, that is 2 sine alpha plus 1 times 2 sine alpha plus 1. All right. Remember, you can't just square each term. You've got to write it out. 2 sine alpha plus 1 times 2 sine alpha plus 1. And now we just FOIL it. So this is going to be 2 sine alpha times 2 sine alpha. That's 4 sine squared alpha. And then let's do this in our head. We've got 2 sine alpha when we multiply the outside, 2 sine alpha when we multiply the inside. So 2 sine alpha plus 2 sine alpha is 4 sine alpha, and then multiply the last plus 1. And there's your answer. All right. So I hope so far all of this is making sense. It's, I mean, right now what we're doing is just kind of a review. All right, and then let's look at factoring. So hopefully you remember how to factor. So to factor this one, well, do you recognize that this is just what? A squared minus b squared is equal to a minus b times a plus b. That's just the difference of 2 squares. And see, in this problem, a is secant, b is tangent. Now, another thing I want to point out, I want to write this down. I'm going to do it up here. The one thing you've got to understand, that this secant squared, and it goes for all of them, but secant squared x minus tangent squared x. So all we're doing is squaring these functions. This is the same thing as secant x squared minus tangent x squared. Okay? It's just this and this, these are the same thing. But it's just easier to write it like this than it is to do like this. So instead of writing the squared, putting the trig function in parentheses and writing the squared out here, we just put the squared right here, or whatever exponent. It could be cubed or to the 4th or whatever. All right. So you can see in this problem here, see, here's your A and here is your B. All right, so this is going to be what? Secant x minus tangent x times secant x plus tangent x. And there is your answer. All right. Now what about this one? Well, then let's factor it. So this is going to be sine beta, and that's going to be what? Plus 2 minus 1. Okay, so it's the same thing as factoring this with the x's. See, that's x plus 2, x minus 1. All right, and the only difference is instead of having x, we've got sine beta. All right, so this is your answer here. All right, so here we want to write each expression in terms of sines and or cosines and then simplify. All right, so this video we're not verifying trig identities in this video. That's the next video. This right here is just getting you ready to be able to verify trig identities. Now, a lot of times when you're verifying trig identities, some of you may already have an idea of how to do it and some of you may not. But to verify trig identities, just real quick, you take the more complicated side and you see if you can reduce it to the other side. That's one way to do it. That's the most common way that you would do it. And when we're taking the left-hand side and we're trying to get the other side of the equation, and if you don't know what I'm talking about, you'll have to watch the next video on verifying trig identities. But a lot of times the way that we start these out is we rewrite everything in terms of sine and cosine and simplify. So that's kind of what this is doing, kind of getting you to understand that. So let's rewrite everything in terms of sine and cosine. So from the identities that we had earlier, we know tangent is sine over cosine. So this is going to be sine over cosine. All right, so that's tangent. And then that's going to be over secant. Well, I need to rewrite secant in terms of cosine. So we know secant is 1 over cosine. All right. So that's just from the identities that we had at the first of the video. These up here. See, tangent sine over cosine. Secant is 1 over cosine. All right. Whoop. Well, went too far, didn't I? Well, there we go. All right. Now, let's look at this. Now, notice I have sine over cosine divided by 1 over cosine. So that's sine over cosine divided by 1 over cosine. Or we can say sine over cosine, and remember, it's times the reciprocal of the bottom. Remember that? Cosine over 1. And then you can see here the cosines cancel, and I am left with sine x. And that would be that term simplified. Okay? And that's what they're wanting in the problem. All right? Let's look at the next one. I've got cotangent times cosine. All right, so let's just rewrite cotangent in terms of sine and cosine. So this cotangent is what? That's cosine over sine times cosine. Okay, you know what? When I copied this down for the video, I copied the problem down wrong. I thought it looked kind of funny. I've got the cotangent times cosine, but it should be sine plus cotangent times cosine. There we go. All right, so let's do this one. So I've got what? I've got sine plus, and then that's going to be cosine over sine times cosine. All right. And so this is sine plus, and then if I multiply this over here, cosine times cosine, that's going to be cosine squared over sine. All right. All right. Now, let's get a common denominator. So our common denominator would be sine. All right. So remember, this is over 1. What do I have to multiply to this denominator to get the common denominator? Well, I got to multiply it times sine, so that means I have to multiply the numerator by sine. And then this one, that's just going to stay, well, that would be sine squared. So this would be cosine squared. All right. So I have to multiply this by sine to get the common denominator. So sine times sine is sine squared. And then those denominators are the same, so that's just cosine squared. And so this would be sine squared plus cosine squared all over the common denominator of sine. And so now, what do we know? Well, this identity here, sine squared plus cosine squared, is 1, and that's over sine x. All right? And then 1 over sine is what? Cosecant. And that would be it. That's simplified. All right? All right, so let's look at another one. All right, so here we've got what? All right, so tangent is sine over cosine times, and then cosecant is 1 over sine over, and then secant is what? 1 over cosine. All right, so it looks messy, it looks complicated, but really it's not. It's not. All right, so, well, let's look at this. Do you see here, if we multiply these two in the numerator together, the signs cancel out, and we're left with 1 over cosine over 1 over cosine, and that just simplifies to what? 1, right? See, the 1 over cosines cancel. Another way you could look at it is 1 over cosine x times the reciprocal of this 1 over cosine x, so times cosine x over 1, which of course that gives you 1. All right, so hopefully you're following along pretty good here. And if you want to see more on this kind of stuff, of course I'll have these other videos. These are the lecture videos, but if you search my channel for proving trig identities, I have a bunch of examples on that. You can check those out. All right, so let's look at this example here. Given that tangent alpha equals -2/3 and alpha is in quadrant 4, find the values of the remaining trig functions at alpha by using identities. Okay, so one way that you've probably already learned how to do this is to draw it like this and label. Okay, we know this would be what? The -2, this would be the 3, and then you would find r, and then you could find all the trig functions like that. All right, but what this problem is wanting us to do is find it using those identities. Sine squared plus cosine squared equals 1. Tangent squared plus 1 is secant squared, and cotangent squared plus 1 is cosecant squared, and then the tangent is sine over cosine, all that stuff. That's what they're wanting you to use, and they're wanting you to use this so you'll have practice using those identities. It helps you remember the identities, and actually later on in a trig course, when you're given like sine or tangent or whatever equals something, and you've got to find cosine, I think it's quicker to find the value of another trig function using these identities. Okay, so let's go ahead and get started. So we've got tangent. So right off the bat, okay, so right off the bat, we know we can go ahead and get cotangent. That is -3/2, because we know cotangent is the reciprocal of tangent. Okay, all right, so now we've got cotangent. Well, what can we find now? Okay, well, we know tangent, and don't we know that tangent squared plus 1 is secant squared? You see that? All right, so now we can find secant, because all we've got to do is take this -2/3 here and plug it in for tangent, and that gives us secant. And then once we get secant, what can we do? Well, once we have secant, the reciprocal of secant is cosine. All right, so let's plug the -2/3 in for tangent. So that's -2/3. I'm plugging that in for tangent, but remember it's squared, so that's squared plus 1 equals secant squared. And so this is going to give me what? 4 over 9 plus 1 equals secant squared alpha. And then when I add these, this is 4 over 9 plus 9 over 9. That's going to be what? 13 over 9 equals secant squared alpha. And so now I get secant alpha is equal to what? The square root of that, right? But remember, it's negative square root of 13 over 3, or secant alpha is equal to square root of 13 over 3. Don't forget, this right here, this secant squared equals this number. That's like x squared equals 9, so x is plus or minus 3. Don't forget about that, that square root property that you learned from algebra. Okay? So now, well, here's a problem we have. We've got that it equals a negative or it equals a positive. So which one is it? Well, let's look and see. Well, it tells us that alpha is in quadrant 4. All right? And we know that all students take calculus. So we know in quadrant 4, cosine and secant are positive. So we get secant is positive square root of 13 over 3. So it's the positive one. Okay? Now that we have secant, we can go ahead and write down cosine. Well, cosine is just the reciprocal of secant. So that's 3 over square root of 13. And then, of course, we'll have to rationalize denominator. Hopefully you still remember how to do that. I'll write it out on this one. So 3 square root of 13 over 13. All right. So how about we start circling some of these? There's cotangent. There is secant. And let's just rewrite. So we got cosine. Well, we'll just leave it like that. And so here is cosine alpha. All right. So far we've got cotangent, cosine, and secant. Now we need to find what? Sine and cosecant. Well, look at this. I know cosine, right? I know cosine. So I also know the fact that sine squared plus cosine squared is equal to 1. All right. So I know what cosine is, so I can plug the value of cosine in and solve for sine, just like I did over here when I solved for secant. Okay, same thing. Now, let's be smart about this. I'm going to write a couple of things down just to show you. So we got cosine is this. So look at this. If I get cosine and I plug that in, then I got to square that. That's going to be 9 times 13 over 9, which, that gives us our value. All right. So, I'm sorry. That's 13. That's 169. I don't know why I wrote the 3 down. All right. So then what happens is, see, we've squared this. Okay, we squared this, and look how messy that looks. So what I recommend, you have to rationalize. You need to rationalize denominator, but that's only your final answer. Okay. Now, are you going to agree with me that this is the same thing as this? They're the same thing. It's just I rationalized denominator to get to here. See, I multiplied by 1. So this and this are the same thing. So why not just plug this one in for cosine? So let's do that and let me show you. Sine squared alpha plus, and then I plug the 3 over square root of 13 in. So that's going to be 3 over square root of 13 squared equals 1. Now, you see how much easier this is? Okay, this right here is a lot easier to square than when we had to square this one. All right, so just plug the one that's going to make it easier. Plug that one in. All right, so we get sine squared alpha plus 9 over 13 equals 1. And then I'm going to do what? I'm going to subtract 9 over 13 to both sides. So I get sine squared alpha. Let's see, 13, that's going to be what? 4 over 13. That's going to be 9 over 9. No, I'm sorry, 13 over 13 minus 9 over 13. Okay, so that would give us 4 over 13. And so now I have sine alpha is equal to negative 2 over square root of 13, or sine is 2 over square root of 13. All right. So remember, we're in which quadrant? We're in the fourth quadrant, right? We're in the fourth quadrant. Sine is negative in the fourth quadrant. So that one gets crossed out. So I get sine alpha is equal to, now I need to rationalize the denominator here. That's going to be negative 2 over square root of 13, and then rationalize denominator, multiply by square root of 13 over square root of 13, and that's going to give me negative 2 square root of 13 over 13. And so here is sine alpha. All right. Now, I've got all of them. The only one I have left is cosecant. So let's see what we have here. So cosecant alpha, well, there's actually a couple of ways to do it. We're going to do it the easy way, but there is a couple of ways. See how we know cotangent? We could use cotangent squared alpha plus 1 equals cosecant squared alpha, right? You could use that, plug cotangent in and solve for cosecant. But why would we do that? But that is something you could do. But why would we do that when we know that cosecant is just the reciprocal of sine? All right. Now look, this right here, we're going to have the same thought process here as when we plug this in for cosine. Yeah, I can take the reciprocal of this, but look, when I flip that, I'm going to have to rationalize the denominator. You see that? Why not just take the reciprocal of this one? So what's the reciprocal of that? Negative square root of 13 over 2. There's your answer right there. Okay? And look, yes, if you would take the reciprocal of this and then rationalize the denominator, you're going to get this. You're going to get the same thing. Just do the one that's easier. Okay? All right, so odd and even identities. All right, so we've got sine of negative x is negative sine x, tangent of negative x is negative tangent x. And then same thing for cosecant and cotangent. And then for the even identities, cosine of negative x is cosine x, and secant negative x is secant x. Okay, that's, you know, I would remember these. You need to remember these. I think the easiest way to remember it is when you have sine of negative x, when you have the negative x in here, I mean, when you rewrite it, the negative comes out in front except for on cosine. Okay, see, it just doesn't do it on cosine, and that's it. And then you know if it doesn't do it on cosine, it doesn't do it on secant either, because they're reciprocals of each other. Okay, so you need to remember those. So let's simplify each expression here and see what we get. All right, so we've got here, well, let's rewrite it. That's what? Negative sine times negative cotangent. All I'm doing, I'm just using the these odd and even identities. That's all I'm doing. So we know this is equal to sine x times cotangent x, right? Because a negative times a negative is a positive. All right, so now let's simplify like we did earlier. So this, let me move this up some. So this is going to be sine times what? Cosine over sine. I'm just simplifying. Cotangent is cosine over sine. Look at there, the sines cancel, and I'm left with just cosine x. All right, let's look at the next one. So this one is what? 1 over 1 plus cosine x, right? Remember, cosine of negative x is just cosine x. All right, that's from the identity here. Cosine negative x is cosine x. And then that's plus 1 over 1 minus cosine x. And so now let's combine these two together. Okay, let's combine them and simplify. So I need to get a common denominator, and that's going to be 1 plus cosine x times 1 minus cosine x. That's my common denominator. 1 plus cosine x times 1 minus cosine x. All right, so let's see what goes up here. What do I multiply to this to get this? What do I multiply to this denominator to get the common? 1 minus cosine x. So 1 minus cosine x, and then here that would be 1 plus cosine x. And so when I add these, I get 1 plus 1 is 2, and minus cosine plus cosine, that's 0. So that's going to be 1 plus cosine x times 1 minus cosine x. All right, so let's see what else we can do here. Well, if I multiply these out, this is just what? A plus b times a minus b, which is a squared minus b squared. We did that earlier in the video. And so that's 1 minus cosine squared x. Oh, look at this. So 1 minus cosine squared, so that's going to be 2 over sine squared. All right. So right now you might be thinking, where in the world did he get that? Well, look at this. If we have, where do I want to write it? Let's write it right here, I guess. So if we have sine squared plus cosine squared equals 1. If I subtract cosine squared to both sides, you see that? See, the 1 minus cosine squared is sine squared. Say 1 minus cosine squared is sine squared. That's one thing about these trig identities, especially those Pythagorean identities. Yeah, you need to know the Pythagorean identities, but you also need to recognize this. If you see 1 minus cosine squared, first thing that ought to pop into your mind is sine squared. Okay, and if you see 1 minus sine squared, you ought to think cosine squared, and then the same thing with the other ones. Okay, you know, you got the 1 plus, or they wrote it. It doesn't matter if you write it 1 plus tangent squared or tangent squared plus 1. See, like this. So 1 is equal to what? Secant squared minus tangent squared. You see that? So if you see secant squared minus tangent squared, you ought to think, well, that's 1. Okay, know the Pythagorean identities and have an idea what they look like when they're solved. Think about them. You know, you should be able to solve those in your head at this point. All right. So now this is what? This is 2 times 1 over sine squared x. So that's going to be 2 times what? Cosecant squared x. And there's that one simplified, because 1 over sine is cosecant, right? All right. Now let's look at this odd and even functions. Now you may or may not have covered this when you took algebra. A lot of you probably did, some of you may not have. we want to determine whether each function is odd, even, or neither. All right, so what do we need to do to show that? Okay, so let me see if I can find me a place to write this. I'm gonna write it. Let's just write it right up here. So if we have f of negative x is equal to f of x, then we have an even function. If f of negative x is equal to negative f of x, then we have an odd function. Okay, so that's how we determine if functions are odd or even. All right, so basically what we have to do to determine odd and even, you can see here, we've got to evaluate the function at negative x. So if I have f of negative x, that's going to be cosine of 2 times negative x over negative x, right? I'm just replacing the x's with negative x. So that's going to be cosine negative 2x over negative x. Now remember, cosine, that's what? Cosine 2x. Remember those identities we had? And that's negative x. All right? So when I plug this in, this negative x into here, did I end up with the function? No. But look at this. Let's take this negative and move it out front. You see that? So what I have now is I have negative, see the negative right here, and then what's cosine 2x over x? Well, cosine 2x over x is f of x. So you can see I got f of negative x is equal to negative f of x, so that means this is an odd function. Okay? And see, if you evaluate f of negative x and you get the same thing back, that means it's an even function. All right, and then this one, well, let's just try this one. So f of negative x is equal to sine of negative x plus cosine of negative x. And so that is equal to negative sine x plus cosine x, right? Using those odd and even identities that we had just a while ago. All right, so I plugged the negative x in. I simplified. Did I get what I started with? No. So we know it's not even. So now what we want to do, let's factor out a negative. All right, so I factored a negative out. There's the negative right there. Now, is this what I started with? No. So I didn't get f of x, and I didn't get negative f of x. So that means this would be neither. All right. Now, I mean, I know these determining odd and even can be kind of tricky. I've got some more videos on my YouTube channel. You can search my channel for odd and even functions. Just search odd, even, or neither. I think that should, or determining if a function's odd, even, or neither. Search my channel for that, and I'll go into more detail. Because that, determining if a function's odd, even, or neither, that's really an algebra topic. We're just doing it with trig functions in this section. All right, so now this problem here is going to kind of lead us into the next section. Okay, the next video or the next section in a trig book, that's verifying trig identities. So, you might have something like this. And here it says, show that sine 2t equals 2 sine t is not an identity. We want to show that it's not an identity. So what does that mean? What does that mean to show that it is not an identity? Okay, what does that mean? Well, that just means that if it's not an identity, that means this does not equal this. Okay? It means they don't equal. Well, they could equal each other for one value, but an identity, that means they're the same for every value. So we should be, if this were an identity, we should be able to take any angle and plug it in and get the same thing on both sides. All right. Now, there may be an instance where you may try to show that this is not an identity. You pick an angle, plug it in, and you get the same thing on both sides. That does not mean that that is an identity. That means it works for that angle. Okay? And so if you take an angle and plug it in for t and you get the same thing on both sides, then try another angle. And if you get the same thing again, then you might be thinking, okay, this may be an identity. I don't know. And then you would have to do what we're going to do in the next video. But for this one, they just want us to show that it's not an identity. So all we have to do is find one angle, plug it in for t, and show that they're not the same. And if we can do that, that means it's not an identity. So I think what I'm going to do is I'm going to try t is equal to pi over 4, which pi over 4, you should know this by now, pi over 4 is what? 45 degrees, right? All right, so let's take the sine of 2t, and I want to plug in the pi over 4, so that's going to be sine of 2 times pi over 4, which that's going to be what? The sine of pi over 2, right? And what's the sine of pi over 2, or the sine of 90? That's going to be what? 1. All right? This is one of the ones that you should memorize. Okay? Remember, if you've watched any of these videos so far in this playlist, I've said over and over and over, you've got to memorize sine, cosine, and tangent of 0, 30, 45, 60, 90, 180, 270, and 360. You've got to memorize those. All right. Now let's do sine of, well, not sine of, how about 2 sine t? So that's going to be sine of, why do I keep leaving the 2 out? Sine of pi over 4. So that's going to be 2 times, and then what's the sine of pi over 4? That's square root of 2 over 2. The 2's cancel, and I get square root of 2. And so we have shown that this is not an identity because those are not the same. And that is the last problem. Now look, there's 5 more videos in this playlist after this one. Okay? There'll be 5 more after this one. If you're watching this video and there's not the videos below this one, then that means I just posted this one and hadn't had a chance to upload the other ones yet. But they're coming. But they should be there, if you're not watching it the day of that I upload it. All right. So, I would recommend going through all of these because, that's what trig is. You start in this chapter of trig identities, and I'm just taking it section by section. Each section has its own video. All right. So, just go through them, and hopefully after you go through them, you'll have a good understanding of trig identities. But I hope the video helped. Check out my other videos. Check out my channel. Give me a like, share, and subscribe. Thanks for watching, and I'll see you later.